this identity. Now, this identity is not very nice. It doesn't look very nice to start with because you're like, oh no, it's cubed. And if you didn't know what else to do, you may well have expanded that cube, okay? Which, as you can see, is a bad idea. Cubing anything is a bad idea, okay? Even though you can do it. Seeing that there's a cos x minus sine x over there, that's my target since I started at the left-hand side, right? I see that I can get a cos x minus sine x out of this by factorizing, right? So remember, even though like simplifying things as far as you can is a good idea usually, always try and think about where you're going. Where's your destination? Because that's my destination. When I look at this numerator, I think about the fastest path to get there. And the fastest path is factorization. It's the difference of squares, okay? Once I've got that, like, and this is the way the trig identity was constructed, you've got this guy common with that thing being raised to the third power on the denominator. So it simply gets cancelled, like so, okay? Which of course is obvious once you see it, but if you don't see it, it's very hard to see. I guess my clue would be, see how it's cubed, right? Like, boy, that's gonna look like a pain. And I'm trying to give you a clue over here on the right-hand side. So as much as possible, and experience obviously helps with this, don't just simplify blindly, or don't expand blindly. Go in a direction. All right, so I cancel. At this point, I know I must expand. And that's because I'm like, look, I want a 1 on the bottom. Where's that 1 going to come from? The best candidate is the Pythagorean identity. Cos squared plus sine squared. Okay? So once that turns into 1, you've already got 2 sine x cos x there, which is already sine 2x. And lo and behold, it just falls out, which is nice once you see it. Okay? Do beware though, under pressure, under time pressure, I would honestly look at this question, and if it doesn't snap into focus in 10 seconds, I'm moving on. That's exam technique, right? You're like, I could waste 8 minutes on this, or I could just move on, get some marks, come back to it, maybe I get it, maybe I don't. Okay, but at least you won't have wasted time on it. Okay, so think about that. Don't get bogged down. Last one. 4 cos a plus 3 equals 0, and tan a is positive. Find the exact value. So there are multiple ways to do this. I felt like the most efficient way was to make cos a the subject so you get a value, right? Therefore, cos a is negative, so I'm in the third or fourth quadrants. Tan a is positive, so I must be in the third quadrant, right? So there I am. And then once that means I've got to fix something. There. Once I've got that, I draw my triangle. If it's 3 over 4, I've got adjacent over hypotenuse, which gives me the other side by Pythagoras, right? Because this guy over here is 16, the square root of 16 minus 9. Is that all right? So that's where my square root of 7 comes from. Now I go through these pieces here. Tan a minus 180, okay? Now the easiest way to see it, is to say, well, tan is periodic every 180 degrees. So tan a of minus 180, you can just read off. That's tan a, okay? Alternatively, if you didn't see that right away, you could say, well, I know how to expand tan a minus b. Tan of a minus b, where in this case b is 180, is tan a minus tan b divided by, help me out, 1 plus tan a tan b, very good. And tan b is 180. Even if you don't remember, your calculator can verify for you that tan 180 is 0, right? So you're getting tan a minus 0, 1 plus tan a times 0, which gives you back tan a, just like we said before. So once you realize that it's tan a, you just read it off the triangle. It's opposite on adjacent, root 7 on 3.